Hello everyone, welcome to this short lesson on rivers. I'm going to focus today on upper course landforms. Now, rivers is a topic that students tend to really struggle with. When you look at a breakdown of exams, it's usually the rivers section that trip most people up. So I'm hoping this lesson is going to really benefit you. First of all, just a quick recap of the hydrological cycle. If you didn't know how this works, the sun heats up the water, turns it into a gas. That's called evaporation. As it moves up and gets away from the surface of the earth, it cools down and condenses to form clouds, and eventually it will precipitate, so rain, hail, sleet, or snow, back to the ground. Now, if it hits an impermeable surface like concrete, or hard rock, it will flow along that surface back to the water or the sea. That's called surface runoff, and then the cycle is complete. If it lands on a permeable, softer surface, it's going to infiltrate down into the soil and then flow through the soil back to the river or the sea, and the cycle is complete. Or it might percolate further down towards the hard rock. It'll hit that hard rock, and then you'll have groundwater flow back towards the river or the sea, and it will complete the cycle, ready to start again. If it lands on vegetation, that's called interception. It's going to block it, and also we have evaporation out of that vegetation as well. So that is also how water can get back into the atmosphere. Okay. When that water does land, it lands into an area that starts to drain that land, and that's called a drainage basin. You might have heard of some of these words before. So the edge of the drainage basin is called a watershed. You've got your main river channel flowing through here, and then each point where the river begins is called the source, and where it flows into the sea is called the mouth. Where it joins another river, we call that the confluence, and a small river or stream is called a tributary. So that is a drainage basin. Now, on the board here, you've got what we call the long profile and cross profile of a river. The long profile shows how a river's gradient changes from source to mouth. So it starts in the upper course where it's really high ground and flows downhill under gravity towards the sea. Most rivers end up at the sea, and that's down in the lower course. And you need to know everything about how a river changes in terms of its gradient. So it goes from steep to flat, how the cross section changes. So it's like a V shape in the upper course, more of a sort of U shape in the middle, and then much flatter in the lower course. You need to know that it starts narrow and shallow and gets wider and deeper. You need to know that the lode size starts really big and angular, which means jagged, and it gets smaller and smoother as you move downstream. And that's mainly because of those erosional processes that are taking place. As you move further down as well, because it's deeper and wider, there's more discharge, which is how much water is flowing every second, measured in cumecs. And it's a much faster velocity because it's got all the momentum here from the upper course pushing down. And there's much more water. When it's deeper, there's less friction, so it's much faster as well. The main processes in the upper course are vertical erosion, more lateral erosion in the middle course, and then we start to get lots of deposition occurring at the mouth, where we get estuaries and things like that forming. So the landforms we're going to focus on is we're going to look at V-shaped valleys and interlocking spurs, and then we're going to look at the formation of a waterfall and gorge. So V-shaped valleys are formed in the upper course, where you've got this vertical erosion cutting downwards into the ground, into the riverbed. And of course, it's not going to stay looking like that. These sides are going to become quite unsupported over time, the deeper this gets. And you're going to have weathering happening on the sides. Things like freeze-fall, mechanical weathering, or chemical weathering. And eventually those sides are going to collapse under mass movement, like rockfalls and landslides. And they're going to fall into this river, and the sediment will wash it all away, and you're going to be left with a V-shaped valley. Simple as that. How that differs to an interlocking spurs is exactly the same. You're still going to have that vertical erosion cutting down, creating these steep V shapes, but now you're going to have bits of hard rock that are kind of sticking out into the river channel. And where the river is using all its energy to erode vertically, it doesn't have the energy to push through the hard rock. So it goes through the soft rock instead and winds around the pieces of hard rock. It's really important that you mention a type of erosion, like with any landform. So you might talk about hydraulic action, the sheer force of the water breaking down the soft rock, or you might talk about abrasion, where the river's carrying material and it's scraping away at the riverbed as well. So you're left with these lovely interlocking spurs. Okay, when we explain these landforms, guys, we use something called PEST, which stands for processes, explanation, sequence, and terminology. And if you can apply pest to any landform, whether it's coastal rivers, you're going to get really good marks. But the most important part of pest is the explanation, explaining those processes. So if you do not know what hydraulic action, abrasion, attrition, or solution is, you have to get right with that. Okay, and I'll use a couple of examples when I show you now the formation of a waterfall and gorge. So these are the best pictures I've ever found when it comes to explaining how a waterfall is created, and that's purely because it's got this first picture. And guys, in your exams, you might be expected to draw this, or you might just have to explain it as like a 6-mark answer. So I would start here. I would draw a picture with a river flowing over hard and soft rock, or I would just say, firstly, a river flows over hard and soft rock, depending on what the examiner wants. And you can see, can't you, where the rock changes here. So this river is going to be flowing over this rock, and obviously the soft rock is less resistant, so it's going to erode quicker. So because of vertical erosion, there's that key term again, and an erosion type, let's just mention, say, hydraulic action here, it's going to start to carve out a bit of a step in the soft rock. So I would say, firstly, a river flows over hard and soft rock and will vertically erode the soft rock via processes such as hydraulic action, which is where the shear force of the water breaks down the soft rock. Okay, the which is where part is where you get big marks. You have to explain the type of erosion. Over time, sequencing word, it will start to create a bit of a step in the soft rock, so our waterfall is starting to take shape. Now, the river will also undercut this layer of hard rocks. This is called undercutting, which will leave behind this area of hard rock, which becomes unsupported. This is called an overhang or a cap rock, okay? All the while, you're also going to have a plunge pool forming, and this water pushing down is going to have more hydraulic action, making this plunge pool even deeper. Eventually, guys, this overhang is going to collapse because there's nothing there to support it. As it does, any hard rock that's in there is going to fall into the plunge pool, which acts as a tool for abrasion, which is where the water picks up all of that material and starts scraping away at the plunge pool, making it deeper and deeper over time, okay, wearing it away like sandpaper. All of these adjectives, all of this description, guys, this is how you're going to get big marks, explaining how that abrasion actually makes the plunge pool deeper over time. Eventually, this process will just keep on repeating. Plunge pool will get deeper, more undercutting, overhang will continue to collapse, and the whole waterfall will migrate upstream, and this will leave behind a steep-sided valley gorge. Okay, and here's just an exam question to kind of apply this as well. So study figure 18, a photograph showing some features of a river in the Lake District. Okay, explain how the landforms, plural, shown in figure 18 are created by physical processes. Now it says landforms, so you're probably thinking, well, what landforms can I see? Well, the examiner in this instance has accepted the waterfall, obviously, as the main landform, but also you can see that this is at the back of a gorge, and they've even accepted the plunge pool, okay, as being a landform. So in essence, as long as you explain the formation of a waterfall or gorge, you're going to get full marks, and you must remember to use pest, okay? You must explain the processes that are occurring. River flows over hard and soft rock, vertical erosion of the soft rock, undercutting, overhang, plunge pool, overhang collapses, process will repeat, and the waterfall will migrate upstream, leaving behind this steep-sided gorge. I hope that's been helpful. Pause it, make notes, have a go at the question, but don't forget to use pest and make sure you explain those processes. That's how you'll get 5 and 6 marks. See you next time.